one feature that is useful to know and interesting about functions is something called a local maximum and minimum values. This is talking about the y values of a function. So the definition of a local maximum is a y value, f of a, where f of a is greater than or equal to f of x when x is near a. Now all that means is that we have a y value that's higher than all the y values near it. Okay, and the way we talk about that is we say that f has a local maximum at x equals a. And then on the flip side of that, we have local minimum values. Okay, we say that f of a is a local minimum value if f of a is less than or equal to f of x when x is near a. In other words, we have a point f of a f of a, that is lower than all the points close by. So let's look at this graph here just to get an idea of what we're seeing there. We're looking for points that are higher than all the points nearby and points that are lower than all the points nearby. And so we have here, okay, a point that is lower than all the points close to it, right? Because if you move to the left or you move to the right, everything is higher than it. Okay, and so this point would be called a local minimum point. Okay, and we'd specifically say that the local minimum value is 1 because that's the y value here. And we would say that the function has a local minimum at x equals 0 because that's the x value. We also have this point right here that is higher than all the points nearby. Because if you move to the left or move to the right, everything is lower. And so this would be called a local maximum point. And we would say that this point, the y value here is 4 and the x value is 3. So we would say that the function f, that 4 is a local maximum value, and that the function f has a local maximum at x equals 3. Now, the endpoints, if you have an endpoint, even though that endpoint is higher than the points to the right, since there's nothing to the left, we do not actually call this a local maximum point, okay? And likewise, on the right side, we have this point that's lower than the points on the left, but there's nothing on the right, so we don't call that a local minimum point. That's just an important thing. It actually goes to the definition, which is actually a little bit more nuanced than what's written here. The formal definition means that there have to be values all around it on the right side and the left. And so we don't ever define an endpoint as a local maximum or minimum point.